Hello, my name is Brad Williams. Today we're going to talk about Tulip and Tulip applied to workstation performance. When we use the term workstation, we use it intentionally to holistically address many scenarios where a company might be interested in assessing the performance and utilization and quality being produced at a workstation. And that workstation might have a sophisticated machine with a controller like a PLC, a programmable logic controller, or a controller like a CNC's controller. And that controller is, of course, controlling the machine, but it can also be used and connected to obtain data related to utilization, production transactions, and reject transactions. So we look at that as one of many scenarios that exist often in the same factory related to workstation performance. The other scenarios are listed here as well. We call supplemental sensors the scenario where there might be a sophisticated controller, but maybe it's closed and it's proprietary and we can't get data from it. Or within that same category, supplemental sensors, it's an antiquated machine or a manual machine that we need to add capability to merely get a base idea of utilization. So in those cases, in both of those cases, what we can do is add hardware, things like a current clamp or a brake beam or a proximity sensor, and Tulip's edge hardware to obtain information that we can then use to derive utilization state and obtain production and consumption production and reject transactions. And then finally, we're very aware that there are many workstations in a factory where there is no machine or not a machine that's conducive to obtaining data from for the purpose of workstation performance. So in those cases, we have to rely on the operator. We have to rely on the operator or technician to give us information. And we want to do that in a way that's easiest for them and doesn't really become cumbersome for them. So we can use hardware to make that easier. And that hardware can be supplied by Tulip or others. And it might include things like a foot pedal or a brake beam or a barcode scanner or even Tulip's vision capability. And using those techniques, we can obtain information more easily. So we're looking at this discussion of workstation performance and how Tulip can be applied to obtain visibility, and also some metric calculations related to workstation performance. And next, we'll go to some demonstration solutions that illustrate this. So today, we're going to look at different roles within the factory, roles from operator to administrator to the folks who digest and consume the metric information, supervisors, foremen, continuous improvement roles, even plant managers. And we're going to start with the operator. So we're going to use this operator station app created in Tulip to describe those three different scenarios. And in each of those scenarios, today we're relying on simulation. And we're going to start with what we call the connected controller. And this connected controller is an app, and an operator interacts with this app, but a lot of the transactions are happening behind the scenes automatically. And in this case, it's through simulation. But that simulation is being done using KEP Server EX, and Kepware is a brand of software that is a basic commodity broker software that fills the need to connect to the controller and expose data from the controller in a way that's easily understood by higher level systems. And today we're using OPC UA as a means of obtaining data. So KEP Server EX is an OPC UA server, and Tulip has an OPC UA client that's reading data from tags that are being exposed. And in this case, we're assuming that this is a CNC controller, and the CNC controller might be like a FANUC controller, and Kepware has a driver for that controller, so that driver converts the information so that we can understand it. So in this demonstration scenario, the operator can produce manually or reject quantities manually, but behind the scenes, a lot of that's being done automatically. So there's the production and reject transactions are happening automatically. There's utilization transactions that are happening automatically, and that's why this utilization timeline, this machine timeline, a standard thing where a Tulip widget that has been configured within Tulip can display the utilization state changes over time here. You might notice that there's metrics being displayed, so actual performance versus target, actual quality versus target utilization, etc., and also unassigned reasons. So we're assuming that this controller is pretty sophisticated. It can give us granular utilization reasons, but not every reason, because of course some reasons relate to materials or labor, um, even job processing, and the controller is not capable of communicating things like it's a break time or there's no materials and therefore no production can occur. So in those cases, we time and date stamp the utilization event, and an operator can, after they resolve the event, of course, can scroll through here and they can see places where they might want to edit an event or assign a specific event for a period of time where the controller is only capable of telling us that the machine is down. So in this operator user interface for the connected controller, the operator can enter production transactions, reject transactions, edit the utilization rate, and also they can view reports. So they can view reports related to performance and quality, utilization and downtime, and those reports can be filtered by shift, day, or week. And these are standard Tulip analytics that have been configured and applied to this Tulip app. All right, so that's one of three scenarios, the what we call connected controller, so data streaming in behind the scenes. And using the same user interface, we can also discuss the other scenarios. And one of those is the augmented operator. So here in this case, we're going to do all of the transactions manually. And that's a bit cumbersome. So sometimes what we can do, and it's hard to illustrate in this specific demonstration, we can use a foot pedal or a barcode scan, and that is what's used to drive a production transaction. Or maybe there's a conveyance of a specific reject, and we can use a proximity switch or a brake beam to capture the quantity of rejects as they pass down that reject conveyor. In addition, here the operator manually enters downtime, and maybe in some cases that can be automated as well with a foot pedal or some means that an operator can easily indicate that the machine is down. So this is an operator interacting with the user interface to provide the data necessary to understand the performance of the workstation. So finally, let's talk about supplemental sensors. And this is the scenario where either the controller is closed or doesn't exist because it's a manual machine. And in this case, what we're doing is through simulation, we are simulating a current clamp that's monitoring the AC output or the current of the power to the machine, and also brake beam sensors for production and rejects. And we have some simulation for that, and that's being done in Node Red. Node Red. So what I've just opened now is Node Red. This might be running on a Tulip Edge device, Edge IO, for example. And it allows us to configure logic related to a part count or a reject count or a current. And incidentally, this is a relatively sophisticated Node Red flow, which we feel that you could immediately use or retrofit in a scenario where you are using a current clamp. And that's something that we feel that can easily be done with a current clamp that we Tulip recommend and our Edge hardware, Node Red, and Node Red communicates directly to the Tulip API through this configurable node. So there are Node Red Tulip Node-RED flows that you can use to configure a solution. So this is the simulation. This is the simulation that's running behind the scenes for this demonstration. And we're assuming, of course, that's similar to the real world. So here, that simulation related to current is being used to drive utilization state changes and also produce and reject. And of course, you can see similar metrics here that we looked at previously. So those are 3 operator workstation scenarios, all supported by this one common app. And we have realistic simulation running behind the scenes that's providing data that's representative of a real solution. Okay, so that's how the data is obtained. But of course, the value is being able to see the data and interact with it. So we have created a workstation visibility solution, and there are a number of asset classes, groups of assets displayed here on the left. And I selected one of those classes, cell B, and these are the workstations within cell B, and you can see that for each performance, quality, and utilization is being calculated for the current shift. I could also filter that by day or week. And the red or green or orange band here, of course, corresponds to the current utilization state, and the configured machine and the time and state is displayed. And the reason I point this out is because this is a standard Tulip widget, machine status widget that is merely dragged and dropped and configured for a given app. And it's very easy to build a solution that displays the current status of the workstation. The way this is designed is we can drill down. We can drill down for a specific workstation and see the targets and actual for those metric calculations for the given shift or day, and also configured standard Tulip analytics related to performance, quality, utilization, and downtime Pareto. All right, so that's how we might provide a supervisor, manager, continuous improvement role with visibility to the data that's being captured at each workstation. So let's transition and start to talk about system administrator and the people who configure a solution like this. One thing we might want to do is build an app related to asset definition and master data definition. So this is a very simple app related to that. We can define asset classes, where a class is a group of assets on a line or in a cell, and also the assets themselves. So here we have some different assets that have been configured, and for each asset, we can define production rate and targets for each of the metrics that we're interested in. Okay, so some simple apps related to definition, visibility, and an operator's user interface. So let's go into standard Tulip, and we'll talk about how these were configured. And actually, what I did want to do, and this reminded me of it, I'm glad I have this here, is what I just showed you was really oriented towards discrete manufacturing and machine tools, where a machine tool is a lathe or a mill that cuts metal. But we don't have to be limited to that, and I'm sure you're aware that we don't have to be limited to a specific type of user interface. So what I wanted to show you today is also a quite different solution for visibility. So again, appealing to manager, supervisor roles. And this is a factory that produces bread, and this is a line that produces dough, so food and beverage. And you can see here we've depicted the factory floor. A blueprint of the factory itself has been imported and now superimposed on top of that the different lines. And we can see for this dough line right here, the current availability and performance, and also utilization state changes over the last hours. You drill down to see some visibility of that line itself, and of course, color-coded information related to current state. So we can see there's a mixing system, a sheeting system, freezer, and again, this is being driven by simulation, but very similarly, the real solution would have KEP server EX underneath it, obtaining data directly from the PLCs that are controlling the line in each of these machines within the line. So utilization state, utilization calculated for each of the different machines, and of course color coded to see current status. We can drill down to the palletizer to see it itself, and even the labeler and robot are being tracked, and we can drill all the way down to that level and see availability calculated for each, utilization state changes over time, and even time and state, that detailed machine timeline with all of the state changes that occurred over the filtered amount of time. And then of course, there's some additional display capability here, so we can look at um, a Pareto of faults and reasons, and also calculated time and state for the different states that are being tracked. So just another example, and just to kind of stimulate your creativity. And certainly, we wouldn't want anyone to leave here just thinking that Tulip can only be applied in discrete manufacturing or for machine tools. It could be applied to any scenario, really. All right, so let's take a look at how machines are configured. So here we are in the Tulip App Builder, and I'm going to start to talk about how we set up the system to obtain data for specific machines, and what that looks like to configure machines. Of course, in the app builder, we're also going to look at dashboards, the ability to create Tulip analytics, and also apps. And we won't spend too much time in here today, but realize that this is the complete integrated development environment or integrated administration environment for Tulip. This is where users are administrated. This is where settings are administrated. This is where access control is administrated. So everything's done here, and we're just going to look at a portion of today pertaining to workstation performance. What I do is, assuming that I want to obtain data from automation from the control layer, we talked about KEP server EX already, and this is where I configure a connection to that OPC server that could exist, of course, at the factory itself, or probably will exist at the factory. And we use our connector host software to obtain data via OPC UA from that OPC server. We have an object-oriented approach to the definition of machines. We create first machine types. So you'll see that there's a number of machines here in my instance. But what I do first is create what we call a machine type. And in a machine type, we configure things like states, reasons, also machine attributes. So this is all the data that's coming from automation. And one of the most important and interesting things here is the logic that pertains to states and production and rejects. So this, as you'll see if you're familiar with Tulip, the concept of triggers and just configurable triggers via drag and drop. This is where we define the logic that drives state changes related to the workstation's utilization state. It's all configurable. It's all straightforward, and we could be comparing different process variables to determine state. If you noticed in that scenario, it was relatively simple. Just an integer being used to derive or map actually to a specific utilization state. Okay, so let's take a look. So we created a machine type. I've already mentioned that there are machines in a machine type. So a machine is where we actually configure the connection to the controller through KEP server EX. So here we can map to, we can browse the OPC namespace and select, how we want to, which tags we want to connect to, and then we map those to the machine attributes that have been defined in Tulip. And that's done here, and you can see the data as it streams into the system. So machine setup consists of course, defining data sources, defining machine types in the logic, and then configuring machines. As we continue to breeze through here, we'll take a quick pass through analytics accessed in the Tulip dashboard capability. And here you can see some analytics. These might look familiar to you. These were what was used in the apps And if we take a look at one of these analytics, I can view them here. I can also edit them here, and you'll see that there's various templates or options for how you configure the analytic itself, and then lots of configuration related to expressions or selecting variables, comparing expressions, configuring colors, date range, things like that that you might expect. So once that analytics defined, then I can of course associate it to an app. So we're going to take a real quick look at app creation today, and this is really the heart of Tulip and key differentiator with Tulip is app building. So of course that's one of the primary things that you do in the app builder is build apps, and this is the app for the operator station that we had taken a look at earlier. And this app, of course, has analytics that display production and rejects. It has the ability to add production and rejects, as you saw as I interacted with it. It has our machine timeline that's configured and buttons, that all provide capability. But this is a little bit busy. We'll create a new step here so that things are a little bit more cleaner to see and to work with. It's a fresh template within that operator station app. So you notice that we're still in the same app. An app consists of multiple steps. So these different user interface elements that you see here are the steps, and typically steps define a flow through the app. Different capabilities within the app, all completely configurable. We also have the ability to link to tables within Tulip. There's the ability to create tables, and a table is just what you might expect, an organization of data in a relational database. We use PostgreSQL, but you don't interact directly with PostgreSQL. There's a user interface that makes table creation and management very simple. We won't go into that today, but rest assured that you can build tables very quickly, and then you interact with them via the apps, and we can define a record placeholder. So maybe we'll work with assets today, and I can create a, uh, a record placeholder. All right. So we have steps, records. You can configure logic related to a step or the app overall. And then, of course, it's very interesting to embed widgets. Widgets are subsets of graphical user interface capability that you can drag and drop onto the canvas. So, buttons, text boxes, number boxes, date selection, drop down list, everything that you might expect. And we can see here there's dedicated configurable user interface widgets related to machines, and those are super helpful. So, all we do is drag and drop one on a canvas. Now, in my solution, of course, I used variables a lot, but here, just for simplicity, we'll kind of like hard code or hardwire these to a specific machine, a pre-configured machine. So here we have the um, color code immediately comes in. We know it's in running state. It's been in that state for nearly 9 minutes. And it's just as simple as that to configure and start to use it. So that's the machine status. You also saw the machine timeline. That's really helpful. I like that one a lot. So if I select a static value and let's say use that same machine, so it just wires itself up. It knows everything about how it needs to be configured and connected to the data. I can decide to show total uptime, maybe hide the key or not. This is that button that allowed me to see the list of past utilization events. So you can see it's configurable, and size, shape, things like that. Very easy to use. So we drag and drop user interface widgets onto the canvas, and you can configure their properties as I just did in the right. So I'll just do some things that we very commonly do. We very commonly with a Tulip application interact with a table. That table could be populated with data from an external source here, or Tulip, of course. Here I'm just going to have data from Tulip itself, and select the Tulip table, and I have that asset table where I've defined all my assets. That's actually not the one, it's this one. And So I have that now connected, and now I can start to map the different columns that I want to display. All right. So it's just as easy as that. I have some data in a table. I can take a look at that if I want to in our test environment or at runtime. This is the test environment. We're on that new step, and there's my data. So just as quickly as that, I made a user interface. Something else that we do quite commonly is use buttons, of course, but what I really want to show you with a button is a trigger, and a trigger is a way to impose logic. So let's just say that we want to edit the ideal production rate, but we only want to do it for values that are 15. So I don't know if that makes much sense, but we can make a button that does that. So this is our way to define logic, to define business rules, to execute, to allow an operator to execute. And I think I forgot something. I forgot to link my placeholder so I know which is a selected row. So that's pretty important because we're going to work with that. So what I'm going to say is for the selected row, table record, selected row, um, ideal production rate is equal to, this is just going to be super simple, a static value 15. So if the selected row has a production rate of that's equal to 15, then we can edit it. Let's just say that. So we're going to store that. Otherwise, okay, so we have some really simple logic. You can test the app and that really simple logic. So I select the row. Is it 15? No. If it is 15, it should change to 99, 999. There we go. So that's just an example, and just obviously just scratching the surface, but hopefully that's helpful in terms of capability. So today we talked about workstation performance. Workstation performance, where we look holistically at the different scenarios that might exist in a factory, including connected controllers, augmented operators, and supplemental sensors. We acknowledge the fact that there might be workstations where there is no machine or it's not conducive to obtain data from machines. There might be scenarios where there's a sophisticated controller or PLC. There might be scenarios where there's a manual machine that we can't obtain data from and we can supplement that with sensors. But in all cases, it might be advantageous to have a common user experience, but certainly it's important that there's common metric calculations to provide comparison across those different scenarios. We hope that you saw that today as we navigated through operator, user interfaces, apps for administrative and also supervisor and manager roles. And then we took just a tip of the iceberg look at the app builder and the means to configure solutions like this. Thank you for your time. We appreciate it.